So today we will learn about scaling. I will introduce all of you to the concept of scaling. Scaling may be what is the purpose of scaling and why it is required, or what are the functions that are performed by scaling that we need to understand. Wait. Scaling may be used to increase or reduce the size of object. Suppose there is an object, there is a 3D object, or there is a 2D object in screen, and you need to reduce the size of the object. So size of the object can be changed. Change means it can be reduced or can be increased with the help of the process which we call scaling. So next important thing is scaling subjects the coordinate points of the original objects to change. That means the coordinate points of the original object changes with the help of scaling, as the purpose of the scaling is to increase or reduce the size of the object. Whenever we are talking about increasing or reducing the size of the object, that automatically means that the coordinate point of the original object which was given has to be changed. Third point is scaling factor. There's a scaling factor which decide whether the object size need to be increased and decreased, and by how much. So scaling factor determines whether the object size is to be increased or reduced. Sorry, wait. Increased or reduced. So this is decided by the scaling factor. Basically, we have understood the process of scaling. It is again, actually, whenever we are talking about 2D transformation, we need to perform several operations to change the shape of the object. So it may be that scaling is one part of the 2D transformation. Now, there is another point, one important point regarding scaling is that if scaling factor greater than 1, then the object size is increased. So scaling factor can be greater than 1. When we are discussing this condition, then there must be another condition where the scaling factor will be less than 1. So remember that if scaling factor is greater than 1, it means the object size is increased. If scaling factor is less than 1, then the object size needs to be what? Tell me. Oh, then the object size needs to be reduced. Then the object size is reduced. So when we are looking at the scaling factor, we are able to understand what type of scaling needs to be done. Now, let us consider a point. Consider a point, we call it object, a point which we will call as object. Consider a point object, or we call consider a point object O okay has this point has to be scaled, has to be scaled in a 2D plane. Sorry, in a 2D plane. Okay, so here let, I'm assuming things, let initial coordinates of the, let initial coordinates of the object of the object O is equal to, these are the given information, x old, wait, let me write x old and x old and y old. So here we will find out the old and new coordinates. Okay, so initial coordinates of what was the initial coordinate of the object here? It is x and y. X, I am representing it with x old and y old. Now Whenever we need to scale the object, whenever we apply scaling factor value, then remember that there will be two values. Okay, so scaling factor for x-axis is equal to sx. Sx x is subscript. Then scaling factor, right, has become smaller. Scaling factor for y-axis is equal to s. So scaling factor for y-axis is s of y. Y is the y coordinate and x is the x coordinate. Okay, wait. Now these are the things. Scaling factor is given, all coordinate are given. So after applying scaling factor, we will obtain the new coordinate values. So new coordinates of new coordinates is, wait, new coordinate O. O is the object. After scaling is equal to x new comma x new and y new. Now we need to add the scaling factor. This is just the mathematical representation that when the new coordinates after scaling y new. So here we can say that the scaling is achieved by, how the scaling is achieved? The scaling, how we achieve, let me write the formula. X new is equal to x old plus sx. Let me make them subscripts so that it is easily understood. And this is the scaling factor for x-axis, not for y-axis. Now, similar thing will be written for y also. Y new is equal to so y new is y old plus S Y. So these are the X new and Y new. That means these are the scaling factor. Now one thing needs to be kept in mind, that in 2D transformation, as I have explained earlier also, each and everything needs to be done in matrix format. So whenever we are talking about that we will insert an object or something, then it is needed that it is done in the form of matrix only. Okay. So this is, wait, let me insert an equation and then I will show you how to write it. And here it will be X new, Y new. These are the coordinate which will be achieved after the matrix multiplication is being done. Now let me write the formula. It is Sx 0, as it is the diagonal matrix. I suppose everyone knows that a matrix whose diagonal element is 0 is known as diagonal matrix. So this multiplied by, let me again write, here it is X old and then Y old. So this is known as, this type of representation is known as scaling matrix. This is called scaling matrix. For homogeneous coordinate, the above scaling matrix may be represented as 3 cross 3 matrix. So the same matrix can, for homogeneous coordinate, whenever we are talking about transformation, it should be remembered that we try to make the coordinate system as homogeneous coordinate system. So for homogeneous coordinate system, it will be, sorry, let me write here. It will be X new, then Y new 1 is equal to, again let me write the formula. Here it is Sx 0 0, here 0, here I will write S of Y. Look, the diagonal elements here represent S of x, S of y, and 1. It means the diagonal elements are the elements that contain the required value. The rest of the elements can be 0 also. Now we will multiply it. Wait, let me again write here. Here we will write, I think it is already clear. We will write the coordinates of x old, y old, and then 1. So this is referred to as scaling matrix for homo homogeneous coordinate representation. So this matrix, the second one, is known as scaling matrix for homogeneous coordinate representation. Okay, so this is all about scaling. Now let us go to the assignment. Assignment is given a square object with coordinate the given coordinate points A. What are the points of the coordinate? A 0, 3, B is A, B, C. There will be 3 coordinates. The coordinates B is 3 and 3. Then there is C 3, 0, and D also 0, 0. Apply the scaling parameter. Apply the scaling parameter to, these are the parameters of the scaling. There were 2 conditions, where scaling factor greater than 1 and scaling factor less than 1. So in this numerical problem, the scaling factor is greater than 1. 2 towards x-axis and 3 towards y-axis, and obtain the new coordinates of the object. Sorry, y-axis. So this is the assignment which can be solved after the completion of understanding of the concept of scaling. Now, since here the scaling factor is greater than 1, so we know that if scaling factor is greater than 1, the object size is increased. It means the size of the object has to be increased.